Oh, man.
All right.
Darn. I've done that before. It's okay.
I know, because then you have one open for like.
Okay, let's see. Let's go back.
I said the following scatter plot shows the number of bags on the x-axis and the amount of red M&Ms on the y-axis. With this graph, we're able to see the pattern for the amount of red M&Ms in the sample for our study. The mean for the graph was 2.39.
All right. Okay, so I know this one
Okay,
has a lot like that linear equation.
Okay.
Let me grab my phone. It has my calculator on it.
Okay. Let's see.
Okay, so this equation.
Anyway.
Go ahead.
No, nothing. You're good. Never mind.
Okay. Because if you look at the equation, it talks about for the y-intercept, is that just 2.0?
I think it's, yeah, I know, because I remember, like, school algebra and stuff that it's just in the equation.
Right.
I'm trying to find.
So 2. Then the other one 1.5.
Yeah, so our y is.
Because if you look at the book under like the introduction to regression,
Yeah, I see it.
that's what it looks like. Is
And the BO is our y, so our y intercept.
okay.
Yeah, I'd say it was just be 2.0.
Okay, so moving on to 5.
That's just 1.5, right? The slope.
Oh, yeah, for slope 1.5.
What is the predicted value when x equals 16? And is that just when we plug it in?
So I'm trying to remember.
And solve for 5? Let's see.
Yeah, so we would plug that in and then times it by that 0.25 and then just do it algebraically, right?
Uh-huh.
That's what I thought.
Yeah, okay. Let's see. So y.
From our data.
Oh, so x is 16.
Mm-hmm. Okay, so I have 1.
Yeah. I got.
Okay.
1?
Yeah, 1 for number 5.
Hopefully that's right.
Okay, now I gotta make a scatter plot for.
Okay.
Good go. Okay, so what do we want to measure in our scatter plot?
I feel like I'm in kindergarten again with the hot dog hamburger.
Sorry, Jensen, you probably have like a horrible view of my head.
Oh, I'm not even looking at it. I don't even know what view is.
Okay, so
of the 3 data shapes.
She watches it. She'll see.
Right. Been a long day. Which shape best describes the data?
Yeah, so it doesn't give us.
So it says out of the 3 data shapes.
Okay.
I'm going to email her this and we'll see how it goes.
You. Workers by.
So what are you
Okay,
putting in as the?
That's what I'm trying to figure out. Don't go there.
Does it say in the previous? Oh yeah, be sure to use the confidence data for the. Oh, what? For the explanatory value variable and the score data as the responsive variable. The confidence and score.
Yeah. There we go. I'm just trying to remember how to do the scatter plot.
It's just under graphs.
Right, but then as far as what do we plug in for like the y-axis and the x-axis?
It says in the previous thing, did you not hear me when I said that? It says to be sure to use the confidence data for the explanatory variable. So I think that would be our y, right? And then it says to use the score as the response variable.
So that would be our x.
I think so, yeah.
All right, let's look.
Because I did it and got...
A hot dog.
Yeah, but it's not like... Oh. Yeah, let's just go with that one.
Oh, maybe I think it's banana.
Yeah, I don't even know. Well,
I
it
would say
doesn't
more like. Go
doesn't
ahead.
really curve. Does it?
Let's try hot dog, and if not,
Okay.
or does it look more like a banana to you?
I don't know, I would think hot dog.
Okay, let's try that one. If not, we'll look at it again.
Okay.
Okay, so based on the shape of the scatter plot, what can you say about the appropriateness of using a simple linear regression to this model?
Okay. Appropriate.
Especially here.
Not reliable, simple regression. Let's see. Well, isn't like the hot dog a normal?
That's kind of what I was thinking.
Yeah, so I think it would be the first one.
Type is a linear pattern.
Yeah, the first one.
But that's if we got the other one right.
How many observations are in the data?
Let's see, observations. Oh yeah, Oh, I think we did the wrong type of scatter plot. Because on here it says to go to... Oh, never mind. That we're supposed to go to the regression. Never mind. That's the other... Shoot, that's the other lesson. Sorry, never mind.
No, you're good.
It's okay.
Jeez.
Would the number of observations just be size?
I'm trying to look it up in the
Not in the book anywhere,
textbook.
or from what I can find. Where did
Yes. So would that just be like,
it doesn't say anywhere.
yeah.
So I know we have 139 numbers.
Yeah, I don't know. I don't know what observation means. Because, I mean, in the data, I mean, we did the and the score. But I don't.
Okay. Let's see. I'll probably just put 109 just as like the sample.
Okay. 109?
139. That's how many sample numbers we have.
Yeah. I don't
Okay.
see an example in the book where it asks this question.
Yeah, I don't.
Okay, so we do need to do that linear regression equation for the y-intercept on it.
I'm just putting my shoes on.
Okay, so elements that line at total.
So we need to get the coefficients then. Jensen, remind me again, what did we decide our dependent was and what's our independent?
For,
Like when we did that scatter graph?
oh.
Isn't it?
Let's see. Y. The confidence data was our Y and the score was the X. So I don't know which one is our independent and dependent.
Let me
Let me see.
It's not the size.
Uh-huh.
It really was?
Yeah.
I was just double checking.
Okay, so I did do the dependent variable being the confidence rating and the independent being the scores. So I've
Okay.
got the coefficients table like she had, or like the book has.
Mhm.
And then from there, it looks like we grab the constant and then the score.
So that would be maybe the numbers on the screen.
Well, let's see. This one's just asking us y-intercept, which would be the constant.
Yeah, just
Which-
the unstandardized coefficient B, right?
Right, so that'd be
1.29.
1.296.
That's the decimals. So we need slope and slope right now.
Okay, slope would be 0.024.
0.024.
Yeah. Or actually, let me think. No, 0.042. Sorry, guys.
0.042.
And what's the predicted value of y when x is 4? Wouldn't it be
Yeah, so we substituted in to just the y.
So
1.464?
that's what I got. 1.464.
What you got?
Yeah.
All the numbers are starting to work.
Okay, so the confidence data go on to 6. What is the max predicted value?
Because there's a positive correlation, we can use the largest x value to find the largest predicted value of y.
What does that mean?
I don't know.
What is the maximum predicted value of y for these values of x? So does that mean we need to plug in 6?
I guess.
For y? And then solve for x?
Yeah.
So we just do the same thing but solve for y again?
Let's see. No, we're going to solve for x.
Oh, yeah.
Right?
Sorry.
Yeah, I think that's what. I don't know.
It says find what is the maximum predicted value of y for these values of x.
Yeah, because y is going to be 6, and then we solve for x to find the largest value. Plus 0.02.
I got 1.328 immediately.
Okay, so what I did then, Jensen, is I put the 1.296 plus 0.042.
Mm-hmm.
And then I did 6 divided by that. Or no, because we would,
Yeah, you'd multiply first. Wait. Wait. We're
it's,
solving?
so it'd be negative, right? Because we'd throw the 6 over.
Yeah.
It'd be negative 6.
Add it and divide, yeah.
Okay, well, if we do it that way, then I have negative 4.67. Which I don't, that would just make our slope negative, I guess. How many explanatory independent variables present in a single?
Wait, so you said you got a negative number?
Yeah, what'd you get? Because now I'm all worried.
Okay, well, because if we add the
Oh, and
1.96 and the 0.042,
okay.
then we need to isolate the x, so we divide that sum. So 6 divided by that sum. Does that make sense?
Yeah, let me. Okay, because it'd be negative 6 divided by the sum of those two numbers, right?
Negative 6?
Because don't we have 6 and y, and then I need a piece of paper. I can't keep it straight in my mind.
Oh, so are we plugging in y as our y-intercept or as like the y of the
So
problem?
I thought we were putting 6 as our value of y.
Yeah, so 6 equals 1
Yeah, and
Okay.
so we'd have 6, and then we'd put the sum of that numbers, and then we got to get it to the other side of the equal sign, right? So it'd be negative.
Well, no, because we are trying to isolate the x. So you just add the sum on that side of the equation and then divide it by the 6, and then x equals that number.
Okay. So
At least from what I understand.
So that'd be 4.48.
Yeah.
Okay. No, that makes more sense.
That makes sense. Okay.
And then 13, I think, is 2.
Okay. Because it's asking independent variables, right?
Mm-hmm.
What about
How many response variables?
Oh, I don't know now. That's the response variable.
so response variable would be the dependent,
Mm-hmm.
which would normally only be 1. Is that an option?
Yeah.
Okay.
We have more than 2, 1 and 2.
I think it'd be 1 because dependent is our constant, so that's what we're comparing against.
Okay.
And 15. Can we say what's the response variable? What is the dependent variable?
So dependent would be the hat size, right?
Yeah.
And then the only thing that
Well,
What is being predicted?
they want to predict the circumference.
That's right. So the circumference wouldn't change it. What would change would be the size of the hat.
Yeah. So the third one? Or
Would be the last one? I could see it being the last one. Because
predict the size of the hat given. Yeah. So it'd be the last one.
Okay.
Yeah, I can throw it through.
Okay.
Hold on.
Okay.
30 ones we missed. So we got all of them right until number 9. Oh, 139 is right. 9, 10, and 11 are wrong, and 12. 9, 10, 11, 12 are wrong. And 13. And 15.
Awesome.
Okay.
Sorry.
With 9, I can switch the 2 variables.
Yeah, because maybe we just did the variables wrong.
Oh, that's going to kill me in the test.
Yeah, I hope she'll probably say what.
Okay, so how to make our score. I guess we need to figure out which is the dependent variable.
Yeah.
So looking at this study, I gotta read it over again.
Okay, so y is the dependent variable
Sure that
and x is the independent.
explanatory. Which one's the explanatory one again?
Let's see. Explanatory is the independent variable, is what it's giving me.
Okay, let me look. So explanatory is independent.
Yeah, so that would be x. So x is the explanatory one.
Okay, and so because up on top of right before question 6, it says be sure to use the confidence data for the explanatory variable and the score data as the response variable. So confidence, so we did have them wrong. I switched them around.
Okay.
But now I have a lot of bigger numbers. I've got 18.690. And then 12.695 for slope.
You can try it. Yeah.
Let's see. So y intercept is the, what did you get for that one?
18.690. And then the slope was 12.695.
Okay.
And then also need to do 11, 12. So again.
Well, if we had 9 and 10 wrong, then obviously 11's going to be.
You just plug in our x.
I don't know if I trust these other numbers. Kind of. So I've got 69.47.
Okay, plug it in right now.
I seriously still don't.
Yeah, that's what I got, 69.47.
I'm worried because it asks us to do 3 decimals and we don't have 3.
Yeah.
Which makes me worried about 9 and 10 again.
I mean, we could put it, just do it, and if it's wrong, then
You try it again.
yeah. Because then we know that we're wrong both ways.
Okay. Pending is score. Okay, yeah, let's just We'll continue and see what's going on. So 12. Because there's a positive correlation, we can use the large value of x to find the lowest.
Well, would we just look at this on our graph?
On the coefficients chart or on which graph?
On on the scatter plot. Did we not make one for this? Yeah, we did. It's talking about how it's a positive correlation, which means it's going upward. So we can use the largest x value on the graph and plug that in to find the largest predicted value of y. Maybe we are trying to find y, not x. I don't know. This is confusing.
Yeah.
I don't know.
We might have to email her about this one.
Okay, then we missed which other ones?
Then we missed 13, which I'm assuming would be more than 2 then.
Okay.
Because then we got 14 right.
So
And then 15 you got wrong, so I would assume it'd be our others.
14's one.
14 is correct. And then 15 you got wrong, so I'm assuming it'd be the third one then. Go with our original gut.
Response variable.
Well, I think
Yeah, Jen. Go ahead.
the last one, because it says the company wants to predict the size of the hat given the circumference. So what's the response variable?
So
They're trying to predict the size of the hat.
So the response variable would be the dependent, so the one that doesn't change.
Yeah. Okay.
If the circumference not change?
Yeah, size, circumference, and length. I mean, the company wants to predict size of the hat. I don't know, because they're trying to predict it off the circumference, so I think circumference would be the response variable. If you say it's the dependent.
Okay, let's try the second one then.
Okay. I don't know.
Yeah, I can fit it and see where we're at.
Okay.
That's a little bit better.
Right.
I'm nervous.
Hey, overall.
Okay, we did a little better. So we got 9 and 10 correct. 11 are correct. 12 is still wrong. We knew that. 13.
Well, it have to be. I guess too.
Yeah, so 13 is going to be 1. And then 15's wrong.
Oh my gosh.
So that one would be.
So 15, I'm still thinking it's the third one.
Yeah, 15 is the wrong one. Do that. And for 14,
14's right at 1.
Just one? Okay. We've gotten... We got one? Okay. I'll go ahead and submit it.
I think it's something like that. So, you know, people do this. Really, out here, out there, around there. Yeah, I know. He's just kind of like.
We should just be missing 1, number 12 now.
Right.
Or complete that.
So the 15 is wrong again.
Oh,
So it's the first one. Holy cow.
Yeah, so it's...
So it's the size
And
of the
then...
hat.
Yeah.
Okay.
And then for number 8, what did you guys get? I think I got...
what number?
Number 8, was it just 9?
Number 8 is 139.
139.
Did we get 13 and 14 right then with
Yeah.
1 on both of them?
Uh-huh. Yeah.
7.
8, 139, 9, 18.690. 10, 12.695. 11, 69.47. 12, we don't have 13, 1, 14, 1, 15, the top one.
Okay.
I will turn it in. Cool.
All but 1. Whew,
Okay.
Jensen, we survived another one.
Yeah. Yeah, sorry I did the wrong prep work and I was just confused the whole time.
No, it's totally
It's
okay.
okay.
We were still confused no matter what. All right, cool. We'll get the that other thing submitted to her as well
I already
tonight.
emailed it to her.
Oh, yeah, we're good.
Okay, awesome. Thanks, guys.
Jensen,
ya.
see ya.